Hello everyone, welcome to today's video. In today's video, we are going to talk about the principal properties of logarithm. Okay, so let's get started. Okay, so principal properties are very important, and if you understand them well and if you know uh, what to conclude from the principal properties, then it's going to help you in solving complex problems on logarithmic functions. Okay, so the first principal property that we will start with is our product rule. Okay, product rule or product property. In some books you will find product rule, in some books you will find product property. Both are same. Okay, and it says that log mn to the base a is equal to log m to the base a plus log n to the base a. So this is the product. This is the product rule. Okay, this is the product rule. Let me highlight it. This is the product rule. Okay, so the product rule says that the log of product of two or more numbers is equal to sum of their individual logs. Understand? Okay, here the condition is m n must be greater than 0, means these numbers must be the positive real numbers, and a should not be equal to 1. Base should not be equal to 1, and a must be greater than 0. Okay, so this is the product rule. Now we have to prove it, right? Because here I have written it. So what about the proof part? Okay, so let's prove log mn to the base a equals log m to the base a plus log n to the base a. Okay, so what we can do, I will start with the right hand side part. Okay, and in the end I will get to the left hand side part. Okay, so the right hand side part says this. Okay, so here my right hand side is log m to the base a plus log n to the base a, right? So here what I will do, here I will assume, let's assume that this thing is x. Okay, let's assume that log m to the base a equals x. Okay, and log n to the base a equals y. Okay, so this is our assumption. Okay, this is our assumption. Okay, now because we assume that log m to the base a is x and log n to the base a is y, so what does it mean? It means if I have to change it into the exponential form, it would be a to the power x equals m, right? And here a raised to the exponent y equals n, right? So here implies and implied on means that this is reversible. Okay, it goes both ways, because when we defined log we did this, right? So this is my equation 1, and I can say this is my equation number 2. Okay, now if you see here, What we need to have here is mn, and how can we get mn from here is only when we multiply these two equations. Okay, so right here, multiplying equation 1 and 2. Okay, if we multiply these two equations, what would happen? Here, a implies ax multiplied by a raised to the to y equals mn, right? So here, a x plus y equals mn. Now, why did I do that? Because I know, because when you have a common base, or when the base is same and the base is raised to the different powers, then powers get added up. So here we made use of, if you remember, we made use of what? We made use of am an equals a m plus n. Okay, so we made use of this property. Okay, so here we got a raised to the exponent x plus y equals m, and now if this is, what is it? This represents exponential function, right? This represents exponential function because a raised to the exponent x plus y equals mn. If you change it to the logarithmic, if you change it to the logarithmic function, then it would be log mn to the base a equals x plus y. Okay, so now further, log mn to the base a equals, what is x? X was here log m to the base a, right, plus log n to the base a. Okay, and what did we do here? Here I'm writing on putting the values of x and y. Okay, so here we got to the conclusion that log mn to the base a equals log m to the base a plus log n to the base a, means that log of the product of two or more number is equal to sum of the individual logs. Okay, so this property is very important, so just have a look at it. All right. Okay, so what we will do, we will do all the properties at once, and then later we will switch to the solving questions part. Okay, now let's go to the next property. Our next property is quotient rule. Our next property is quotient rule. Our next property is quotient rule. Next property is quotient rule. All right. So let's do number 2. Property number 2 is quotient rule. Okay, and it says log m by n to the base a equals log m to the base a minus log n to the base a. Okay, so So this is the quotient rule. This property says that uh, log of m over n to the base a equals log m to the base a minus log n to the base a. Okay, so you just have a look at it, and then we are going to get the proof. Okay, we'll prove that this is equal to this. Okay, so proof is quite easy. Let's do the proof part. Proof is quite easy. Why? Because we're gonna do, or we're gonna make the same assumptions here that we did in the previous property. Okay, so let's assume that let's assume that that let's assume that log m to the base a equals x, right? And log n to the base a equals y. Okay, from here I can say ax equals m, and from here I can say ay equals n. Okay, this is my equation 1, this is my equation 2. Okay, just have a look at it. Then now if I got these two equations because I made some assumptions. Now if you look at the left hand side, what we have, m by n, right? M by n. And how can we get m by n if we divide equation 2 by 1, right? So here, what I will do here, dividing equation 2 by equation 1. Okay, if we divide equation 2 by 1, then what would happen? Then here would be, which implies m by n equals ax by ay, right? And which further implies m by n is equal a x minus y. Okay, because this is one of the property of exponential function. When you have the properties, see here, am by an equals am minus n. Okay, so we are just making use of this property here. Okay, then if you further, now this represents exponential function. Okay, and if I have to change it into the logarithmic, so what I will do, it will be log m by n to the base a is equal x minus y. Now you put the values of x minus y, so it would be log m by n to the base a equals, the value of x is log m to the base a minus log n to the base a, right? And how did we get it? On putting the values of x and y. Okay, so on putting values of x and y, we get to here, which says log m by n to the base a equals log m to the base a minus log n to the base a. This is quotient rule, very important property. Okay, so please try to memorize these properties, or when you are going to work on its proof, and you will do it several times, then automatically it will stay in your head for long. Okay, um, so these are the two main properties. Now let's go to the next property. Our next property is property number 3. Our property number 3 is, it is a power rule. Okay, our property number 3 is power rule. Okay, and what does it says? It says that if it says that log of a raised to, or log of b raised to n, because we are just making because previously whenever we did the general cases, we always took b, right? So here we'll keep it, or you can just go for x. Log of x raised to exponent n to the base a is equal to n times log x to the base a. Okay, this is very important property. Okay, this is power rule, which says that log of x raised to the exponent n is equal to n times log of x, means the power will get multiplied. Understand? So to work on the, we need to work on the proof. Okay, so what we'll do here, first we have to understand what does x raised to exponent n means. Okay, so see here, xn, what does it mean? It means x times x times x times x and n times. Yes or no? Right? N times, right? That's what x raised to n means, right? So if I take this side, log x raised to the exponent n, so it's going to be log x, and here it's going to be plus y. Okay, see here, xn, right? Xn, here I can write x into x into x into x n times. Okay, here you will have more clarity. Okay, this way. So now if you look at this, you can use what you can use here. You can use the product rule, which says that log mn to the base a equals log m to the base a plus log n to the base a. And I said that here in product you can have two or more than two numbers, and here you have x how many times? N times. So here it would be log of x to the base a plus log of x to the base a plus log of x to the base a, so on. Now how many times this thing will happen? N times. Okay, so what does it mean? It means it is n log x to the base a, right? So that's what it says. So therefore log of x raised to the exponent n to the base a is this. Okay, so hence proved. Okay, so this is very important. This is power rule. Okay, so what does it mean? It means if you take log of a number raised to some power n, then the power will get multiplied. Okay, and here the conditions are same. Here x must be positive real number, a must be greater than 0, and a should not be equal to 1. I don't remember in the previous properties 1 and 2, and there the conditions are going to be the same. Mn, because in product rule and in quotient rule we used mn, right? So mn, both are going to be positive real numbers, and a should be greater than 0, and a base should not be equal to 1. Okay, so that's it about power rule. And then we have fourth property. Fourth property is also important, and property number 4. This is property number 4. Okay, property number 4, what does it says? There is no particular name for it. I'm just going to write here property 4. Okay, and what does it says? It says that a raised to log b to the base a equals b. Okay, so property number 4 says that if you raise a to the exponent log b to the base a, then the answer will be b. What does it mean? It means that something will happen that will automatically cancel this part, and you will be left with b. Okay, so let's see if this is true or not. So here, when we define log, we said a x equals b, right? And here, a, b must be greater than 0. A should not be equal to 1, right? A should not be equal to 1. Okay, so here ax equals b. What is it? This is exponential function, right? And log of b to the base a equals x. This is logarithmic function, right? And both these functions implies and implied on means they are reversible, right? So what could happen here is that we need this. So if we put value of x here, like this is 2 and this is 1, so putting the value of x from 2 in 1, what will you get? So this you can put here. We will get a log b to the base a equals b. So this is the result. Okay, this is very, very important property too. Okay, so a raised to the exponent log b to the base a equals b. Okay, now I will just summarize all the properties that we did in this session. Okay, and then we'll work on the questions. Okay, so here on this side, I will summarize all the properties. Our first property was log mn to the base a equals log m to the base a plus log n to the base a. Mn greater than 0, a greater than 0, and a is not equal to 1. Second, log m over n to the base a equals log m to the base a minus log n to the base a. Property number 3 was power rule, which says that log x raised to exponent n to the base a equals n times log x to the base a. And number 4 is number 4 was a raised to the exponent log b to the base a equals b. Okay, so these were 4 properties that we did. Okay, now let's start with the question parts. Okay, I hope you can see the things written over there.